Hello, welcome back. I bet you haven't quite had enough of exponent rules yet, haven't had your fill, aren't confused enough yet. So we're going to add some more there to you. We're going to start with our first property of the day today, which is our zero property. Any number to the zero power is 1, not 0, 1. And I've shown you an example of why that works. So 3 to the third is 3 times 3 times 3, and that's 27. 3 squared is 9. Well, we dropped this by 1, and here we divided by 3. So that means if we drop by 1 again, and we divide 9 by 3, we get 3. So when we drop by 1 again, we will divide 3 by 3, and 3 by 3 is 1. That's why this works. As you guys know, I'm all about the why. So just remember, any exponent where you have that base a, whatever that number is, to the zero power, it will always be 1.
So the next one we're going to talk about is the power of 1. So that states that any number to the power of 1 is the base number of itself. So as you can see, if I take a to the first power, we're left with a.
Remember, it's not 1. Those are the big things you're going to get screwed up with. Just like if you take 1 to any power, it's 1, not whatever the power is. And our third one is for negative exponents. This one's probably the one that will hang people up. So since when a base has a negative exponent, you're going to put that power under 1 to turn the exponent positive. And I know that sounds super confusing, and it looks like this: a to the negative n equals 1 over a to the n. I equate this to a snowball fight. If Mr. Penn-McGree and I are on the same team for a snowball fight, we're making snowballs, and all of a sudden he thinks it's funny to decide to start pelting snowballs at me. Well, I love a good snowball fight, so I wouldn't mind it too much. But if we're trying to win the snowball fight, I'm not going to be real happy. And what am I going to do? I'm going to say, get off my team. So he's going to go to the other side of the snowball fight, to the other team, and he's going to still be throwing snowballs at me, except before, when he was on my team throwing them at me, that was a negative thing. Now that he's on the other team throwing at me, it's a positive thing for his team, which is why switching it to the other side of the fraction bar makes it positive. So let's take a look at how these apply to some examples. So our first one is 3a times negative 4a squared to the zero power. If you want to get technical, we can take this and say that this is really negative 4 to the zero power times a squared to the zero power. But if you can recognize that because all of this is being taken to the zero power, that follows our rule of 1, you can jump right to 3a times 1, which is 3a, which is probably a lot easier than going, well, negative 4 to the 0 is 1, and a squared to the 0 is a to the set is still a to the 0, which is 1. That's a whole lot of extra work.
So the next one we're going to take a look at is we've got 3ab to the fourth times 4ab to the negative third. So now what we're going to do is we're going to take that 3 times 4, which is 12, and then we're going to have a times a, which is basically a to the 1 plus 1. And then we're going to have b to the fourth times b to the negative third, or 4 plus a negative 3, which then is what? 4 minus 3 is 1. So we're left with 12a to the second power and b.
Now, some of you might have been going, well, that's a negative exponent. Couldn't we have just put it to the other side? Yes, but that creates a whole lot more work. Always see if you can combine them and create a positive exponent like we did here first, because it'll make your life a lot easier in the end. All right, this last one has a division plus negative exponents. The way I like to look at this is if you have negative exponents, I mark them and I kick them to the other side. So I actually physically draw arrows to switch them to the other side, because then that way it makes it easier to organize your thoughts. So I still have a 12 on top. The a cubed didn't go anywhere. B to the negative 4 is gone, but I got an a to the negative 2, which is now a to the positive 2. And initially I'm just going to write out what I've got before I start combining. On the bottom I still have the 4 and I still have a b, but now I also gained a b to the fourth because the b to the negative fourth becomes positive. So now I've got 12 times a to the 3 plus 2, which is a to the 5th. And then I've got b4 times b to the 1 plus 4, which would be b to the 5th.
Now, can't we simplify that fraction? 12 over 4?
Absolutely. We know that 12 divided by 4, when we divide those both out, give us 3 over 1. So this actually means that my final answer is 3a to the 5th over, you could put 1b to the 5th. I'm a typical mathematician and don't like to have any more writing than I need to, so I'm just going to put b to the 5th. So hopefully we had a little bit of a taste of what's going to come. And I want you to give these 4 you-try problems a shot. We got one with the power of 1, one with the power of 0, two with negative exponents, one with that's a power of a power, and see what you can do with them and bring your questions with you to class tomorrow.